Hi, my name is Dan Pomeroy. I'm the co-founder and co-director of the Scientific Citizenship Initiative. We're a nonprofit organization that supports a growing civic science movement. At SCI, we envision a future where science and society work hand in hand to address our most pressing challenges in ways that advance equity and justice. This lecture is the opening session of an interactive workshop series designed to explain the role science plays in public policy, provide actionable strategies for engaging with policymaking audiences, and give participants the opportunity to practice science communication skills. If you're interested in learning more, feel free to reach out to us. So to begin with, what is science policy? It turns out this is a rather ambiguous phrase. In reality, there are two different types of science policy. One is science for policy, and the other is policy for science. Policy for science encompasses all of the policies that guide the scientific enterprise. The public policies that most impact how science is conducted in this country often revolve around federal funding for science. So as you can see, some major topics in this category of policy for science include how federal funding is allocated among various scientific agencies, which new priorities and initiatives are funded, and what kind of scientific infrastructure the federal government is willing to invest in. However, these are not the only examples of policy for science. There are policies regarding how scientific training is done, policies that try to increase diversity, equity, and inclusion in science, and even intellectual property rights regarding how scientists can use their discoveries to commercialize new businesses. Science for policy, by contrast, refers to how scientific research informs public policy. For example, atmospheric science can track the rate of warming of the planet, which is really important for climate change policy. Fluid dynamics can tell us what happens when you cough and sneeze, which is important for how infectious disease policy is set. Nuclear engineering can look at the various ways that nuclear waste can be disposed and identify which ones are the most safe and which ones are less safe. Now, I want to add a word of caution. When engaging in science policy, whether it be science for policy or policy for science, it is important that you know your values and how they're impacting any recommendations you may make. Oftentimes, scientists think that because they're the experts, policymakers should just listen to what they say, when in reality, policymakers don't have to listen to scientists at all. It turns out science is actually just one of many inputs to public policy. Critical factors like public opinion, economics, values, and a variety of other considerations all play an essential role in setting public policy. In fact, as we'll discuss in later lectures, public policy isn't even made by one organization. It's made through a complex interaction of many different stakeholders, each of which has a different point of view and a different set of values that they're applying to solve any policy problem. To show the limitations of science, imagine we're studying the health impact of some evil toxin Z. Research can quantify the increased risk of cancer due to the exposure of the chemical. However, science can't say on its own what is the safe level of evil toxin Z. It could be here, or it could be there. This level depends on society's tolerance for risk and therefore has to be decided through a complex interaction of many different stakeholders, evaluating their own risk and coming to some kind of agreement about what the safe level of this toxin would be. Most of science policy engagement can be categorized into three different modes. First and most straightforward is just providing the science. So for example, a scientist could provide this graph to a policymaker and say, here's what science knows about the increased risk of cancer as the public is exposed to this evil toxin. The next step a scientist could take is evaluating policy options, saying, here's the impact of setting the safe level here versus setting the safe level there. And finally, scientists can also make direct recommendations of what they think the limit should be. In each one of these cases, a scientist is imparting some amount of personal values into the situation. Even when you're just providing the science, it's important to remember that science itself is not values-free. Scientists make values-based decisions all the time. They decide what to study, what methodology to use, and what is considered sufficient evidence for conclusions. Similarly, when evaluating policy impacts, you're actually imparting your own personal values. Impact can be evaluated in many different ways. Are you talking about economic impact of the companies that produce this evil toxin? Are you talking about the increased strain on our healthcare system? Or are you talking about pure human mortality or even quality of life? What kind of impact you choose to evaluate can often frame the policy discussion that happens after the fact. Then obviously, when making direct policy recommendations, you're applying your own personal values very explicitly to say what level of risk you would be comfortable with in the situation. As we'll discuss in this course, a policymaker always wants the most direct recommendation possible. Therefore, as you move from left to right in this diagram, you're more likely to have an impact on any particular policy issue. However, as you move from left to right, the degree to which personal values influence your statements about the policy issue also increases, requiring careful reflection on how those values shape your conclusion. This plays out not only in the realm of science or policy, which is what we're talking about in the previous slide, where science evaluates the health risk of an evil toxin, but it also plays out in the policy for science side of things. In the case of R&D spending, societal values have a huge impact on what the federal government chooses to fund or not to fund. You can see this in these two charts from 1976 to 2020. The share of the federal funding going towards health sciences dramatically increases, while the amount we spend on NASA or even energy has decreased. This is an indication of what society values and what people in the country want to spend federal research money on. Now, I want you to take a moment and think about a policy recommendation you might make. What scientific evidence supports your suggestion? What personal values shape your perspective? Can you distinguish between the two? Now take it a step further. Why might someone with a different set of values look at the same evidence and reach a different conclusion? This is the heart of effective public policy engagement, understanding not only how science and values intersect, but also how others' perspectives come into play. Co-creating equitable and inclusive policy solutions means recognizing and integrating diverse viewpoints to ensure that the outcomes are both just and impactful. And with that, I'd like to thank you for listening to the introductory lecture of SCI's Science Policy Workshop series. If you share SCI's vision for a world where science and society work hand in hand, we invite you to join us and continue to grow the civic science movement.